Okay students, welcome back to another video. In today's video we'll be doing second part of October-November 2023 paper of physics variant 3. So the question number 7 says figure 7.1 shows an electric field pattern around point X. On figure 7.1, draw an arrow to indicate the direction of force on the negative point charge placed at Y. So this is a positive charge and this is a negative charge at point Y, and we know the patterns are outside, so it's a positive charge, and this will attract this negative charge towards its center. So this is the direction of force on this negative charge. State what is at point X producing the field patterns shown in 7.1. We know positive charge has field patterns which are directed outside the charge, and negative charge has field patterns that are directed inside the charge or towards the charge. So this charge is surely a positive charge, so I am writing a positive charge over here. Now the next question says a piece of plastic is charged positively by a friction. State what charge transfer occurs during this process. So for this we need to know few facts that atom is overall neutral. Why? Because number of protons inside it is equals to number of electrons inside it. That means the amount of positive charge inside an atom is equals to amount of negative charge inside an atom. So they cancel the effect of each other and overall atom turn out to be neutral. If atom loses an electron, the number of proton inside it become more than number of electrons. So it becomes more positive and it is positively charged then. So the answer to this question is by friction, the electrons of the plastic are transferred and it loses electrons, hence become positive or positively charged. Next question says explain how the structure of electric conductor differ from the structure of electric insulator. We know that electric conductor has more electrons, free electrons. So I'm writing conductor have free electrons, but insulator do not have free electrons. That's why they don't conduct any electricity and heat as well. Okay, next question says that figure 8.1 shows the single turn coil of simple direct current motor. So this is a coil inside magnets, and explain the direction of turning effect as seen by an observer at point O. So what will this observer observe from this position? Let me just draw the direction of current first. This is the direction of current at this end, and this end the direction of current is towards U. So according to Fleming's left hand rule, if the direction of magnetic field is towards right and the current is towards U, then the force will be upward. So force will have this direction at this end, and for this end the force will be downward, because if the current is towards the screen, the magnetic field is towards the right, then your thumb will point downward and the force for this end of the coil would be downward. So this upward and downward force will create a couple or a torque or a turning effect, you can say, which will rotate this coil. And from these force you can observe the coil will rotate anti-clockwise. Direction of torque is anti-clockwise. Now the next part says the coil is replaced by an otherwise identical new coil with 3 turns and the current is same. Okay, what will happen to the turning effect now if you replace this coil by the coil which have 3 loops? So you know that the turning effect or the force depends upon current, magnetic field and number of turns. If you increase the current, the force will increase. If you increase the magnetic field, the force will increase, and Similarly, if you increase the number of turns, the force will increase, the torque will increase. So if we have more turns now, the torque will be more. That means the turning effect would be more. Now, third part says that this time we are replacing our coil by 3 times greater resistance wire. And what will happen to the turning effect now? So, we know that if the resistance would be greater, it will block more current. And if the current is blocked more, the current will be reduced. And for less current, we'll have a less torque. So, torque will decrease. The B part of the question says figure 8.2 is a voltage time graph showing the output of simple alternating current generator at time t naught. At t1 it is maximum, and at again t2 is minimum, and t3 it is negative maximum. Figure 8.3 is an end view of the plane of the coil of generator at time t naught. The coil is rotating clockwise. Okay, so the coil motion would be clockwise. This is an important point. So this is an end view of the coil. Let me draw the 3D shape of the coil for you. It would look like this. It would be vertical. And the 2D end line view, I'm just drawing it with the green pen. It would look like this. A would lie upside and B would lie downward. So A would be here and B would be here. The thing to be noticed is that it will go clockwise. So it will have a clockwise motion. A will go downward up when it starts rotating. And at this point, there is no current. That means there is no flux, or we can say that this coil this time is parallel to magnetic field. So either the magnetic fields are coming from up to down or from down to upside. So no flux. Okay, now the first part of the question says draw an end view of the position of the plane of the coil at time t1. Include the labels A and B. So at t1 the current is maximum. So the position of the coil would be totally opposite to this. If this is vertical, then at this time the coil would be horizontal. And we can see that if the coil has moved clockwise, the A would come left side and A would come right side and B would come left side. And at this point, the end view of the coil will look like this. And at this point, if the current is maximum, that means magnetic flux through it would be maximum. So magnetic field patterns would be like this, or from down to upward, you can say. The second part says draw an end view of the plane of the coil at T2. At T2, again the current is minimum. So it will have a very similar shape as the question has given us. Again vertical, because again the current is minimum. But this time the coil is rotating clockwise. So see, the A will come downward and B will come upward. So the end view of the coil will look like this. A would be downside and B would be upward. Again, the current is minimum, no current, no flux, and the end view will be a straight vertical line with B upside. Draw an end view of the position of plane of the coil at T3. Include the labels A, B as well. At T3 again we know the current was maximum, so it would have again a horizontal position, but this time the position would be opposite to the one we have drawn earlier. So the position would be vertical, but this time A would come on the opposite side. A would come on this side and B would come on the right hand side, and the end view of the coil will look like this. Ninth question says for each application of radioactive isotopes, state and explain which type of radioactive emission is suitable and suggest an appropriate half-life for the isotope. First one is household alarms. And for household alarms, we use alpha particles because they have very less penetrating ability. And to explain this, let me just explain you the working principle of household smoke alarms. So there is a sensor on which there are continuous rays of alpha particles. And when there is fire, there is smoke, and the smoke blocks the alpha particles, and the sensor start beeping because it's not getting appropriate amount of alpha particles as it was getting before, because they were getting absorbed by the smoke. So it will start beeping and we will detect the fire. To explain this, we can write, because alpha particles are low penetrating and they get easily absorbed by the smoke and trigger the alarm. And half-life, you can write any half-life between 50 and 500. Next is measuring the thickness of aluminium strip produced in a factory. We can use beta particles or beta rays for it. And why do we use beta rays? Because they have very suitable penetrating ability between alpha and gamma, and their absorption depends upon the thickness of aluminium sheet. So they can measure the thickness of aluminium sheet very well because they are get absorbed by very few millimeters of aluminium. And you can write any half life for them. I am writing 50 years. Part B says lead 208 has highest nucleon number of stable isotope of lead. Explain why lead 214 is radioactive. Why any atom is radioactive? There is a very simple explanation to it, that it has higher number of neutrons than protons, and it has to decay few numbers of neutron to become stable. So we can say it is radioactive because it wants to become stable, the first point. And the next point, that it emits or it loses some of its neutrons. Sorry, I've written nucleons over here. It's neutrons. State two different sources of background radiations. We know first is cosmic radiations, and next one I am just writing food. You can write any background radiation. There are medicines, rock radiations, any of them, but I am writing two of my choice. Question number 10 says that what is H naught? What symbol in space physics represent H naught? It's Hubble constant. And question number 2 says write down the equation that defines H naught in terms of speed that a far galaxy is moving away from Earth and its distance from the Earth. So we know there is very simple equation for H naught, which is the speed of galaxy from the Earth and distance from the Earth. Or we can just simply write it as V over D. The numerical value of H naught is 2.2 10 raised to power negative 18. State the unit of H naught. As it is speed over distance, so it will obviously have a unit of seconds. I'm writing it over here. Part number 3 says use this value of H naught to determine an estimate for the age of the universe. We can determine the age of universe by taking a reciprocal of H naught, or we can say 1 over H naught. So age of universe would be 1 over H naught. The value is already given by the question, which is 2.2 10 raised to power negative 18. When you put it into your calculator, you will get 4.5 10 raised to power 7 seconds. State when cosmic microwave background radiations was formed and where we detected. They were formed from the beginning of the universe, from Big Bang, and we can detect it from any point in the universe. They exist everywhere, so it comes from every point in the universe